Hello there, welcome to the Learning of Engineering tutorial video lecture. In this video lecture, we are discussing about the thin cylindrical vessels. As we know, these thin cylindrical vessels are widely used for the transportation of the fluid from one point to the other point, or to store the fluid in a respective places like petrol bunks or the water tanks. These are going to become to the thin cylindrical vessels. So not only that, when we are going to be store the fluid inside that containers, and then automatically it will exert certain pressures on the cylinders. So in order to understand the response of the system and to understand in terms of the stresses and the strain, and here we are trying to find out the shear stress in the material. In the last video lectures we have seen what is the circumferential stresses are acting and what are the longitudinal stresses are going to be acting on that member. So that example I had given, can you see, this is going to be the inside, we do have a fluid is going to be existed and it is exerting the pressures on the walls of the cylinder, and that we can see in the transverse axis and in the longitudinal axis it is going to be acting. So in this direction I can say this is going to be the sigma c, that is equal to that I am going to be say that is the circumferential stress is going to be the sigma 1, and the longitudinal stress I said that is going to be the sigma 2. And we do have calculated that the circumferential stress in the material, that sigma 1 is equal to Pd by 2t, we got it. And similarly the circumferential stress that is longitudinal stress is equal to sigma 2 is equal to Pd by 4t, we got it, right? And these are the magnitudes, those are acting in the respective direction. Now we know if you take any point of this, suppose I am going to be considering this is the part of the material. This means this part, that means the point in that material also subjected to the circumferential as well as the longitudinal stresses. That means the two principal stresses are going to be acting on that member. Suppose if I am going to be taking this one, I am going to be taking the member going to be in this three-dimensional object. So then what happened in this side? This side is going to be the sigma 1 and this side is going to be, can you see here, this side is going to be the sigma 2, that is going to be where longitudinal stress is going to be acting. So then how to find out the shear stress? That we can say the maximum principal stress. As we know, so from the principal stress and principal strain theory we have adopted, that's going to be tau max is equal to, we are going to be taking, that's going to be sigma 1 minus sigma 2 by 2. So this is the equation we are using to calculate the shear stress existed on the member. That means at any point, suppose you can take this point also. So on this point, what is the shear stresses are existed? You can take any point on this material, we can use this equation to find it, because the principal stress is going to be acting in the circumferential direction and the sigma 2 is going to be the longitudinal direction, the loads are going to be acting. So these are all things are coming that because of the fluid pressure existed at certain conditions, then that's going to be creating a certain forces on, and the resistance forces are going to be developing, and automatically stresses are also going to be building in that material, right? So this way we are going to be calculating. So whenever I am substituting the sigma 1 and the sigma 2, now I am going to be defining the shear stress in terms of the dimensions of the component and the pressure. So the tau max is equal to sigma 1 is equal to Pd by 2t minus Pd by 4t divided by 2, we got it. If I am going to be simplifying this equation, and that's going to be denominators and numerators, then I got it finally, the tau max is equal to Pd by 8t, I got it. So there we can see sigma 1 is the maximum circumferential stress is going to be acting, and sigma 2 is going to be 2 times less, and tau max is going to be 4 times less to the circumferential stress. So this is the way we are going to be calculating the maximum shear stress. Now we can see the efficiency of a joint. This is mainly the construction problems are going to be arising. Suppose if you want to convert the sheet in terms of the cylindrical vessel or spherical vessels time, so we can't make it the complete in the cylindrical form. So then what we are going to do? That means half of the cylindrical vessels we are going to be preparing, and then we are going to be joining with the either welded joints or maybe the riveted joints we are using. In that case, suppose you are using the riveted joints to joining of the two plates. So then what will happen? Suppose this is going to be your cylindrical vessels. Can you see here? So in these cylindrical vessels, what will happen? We are going to be making, that means two circles. That means I am going to be taking over here in these directions. So can you see? The first half of is going to be this one, the second half this part. So then I am going to be clubbing these two together by the riveted joints. While using the riveted joints, what will happen? Either you are using the lap joints or maybe the butt joints they are going to be using. Alright. So then in this case, we are removing the store. So we need to insert the rivets inside the material. So then what happened? We will try to remove the load. So we are trying to remove the material. So then what will happen? We are going to be making the holes inside the material. So can you see, when we are removing the material, automatically what will happen? Some resistance force offering by that material is going to be reduces. Right? So this is going to be the case like this. This is going to be the plate we do have, and the loads are going to be acting in these directions. Right? So if I am going to be removing the material over here, so then what will happen? The stress concentration is going to be built around the material, that is the vacant position. And similarly in this case also the stresses are going to be built. So then what we are going to do it? So we need to take the consideration of that efficiency of the joint. So that means whatever the circumferential stresses and what are the longitudinal stress we are calculating, it is not the appropriate one. So then we need to be introduce the term that is going to be efficiency of the joint. So there we can see when the circumferential load is going to be acting, so then the longitudinally the material will going to be start to splitting. When the longitudinal stresses are going to be acting, so then what will happen? The circumferential, the material is going to be removing. That means the material will going to be separating in the cross, the circumferential direction. So then what I am going to do? I am going to be introducing the term. So then when I am going to be taking the joint of these two material in the longitudinal direction, that I can say the longitudinal efficiency of the longitudinal joint. And I am going to be joining in the transverse direction, this material. So then what will happen? That I am going to be say the efficiency of the circumferential joint. So there we can see when we are removing the material, then the strength of the material is going to be decreases, and that we are going to be taking. That means suppose without having the hole, so that can show 100% of the resistance. When the material is going to be removed, so then what will happen? The efficiency of that component is going to be decreases to 90% or 80% or the 70%. So then what happened here? When the circumferential loads are going to be acting, the longitudinal joint is going to be suffering. So then this equation I am going to be modifying, sigma 1 is equal to PD by 2T. So when the efficiency is going to be decreases, what will happen to the shear stress? It start to increasing. It means very clear that it is going to be inversely proportional to the stress. So that's going to be epsilon L I am going to be taking here. So can you see? So sigma 1, this is going to be circumferential stress, PD by 2T, and now we did the riveted joints here. So then the efficiency is going to be decreases. So that's going to be L we are going to be taking. And similarly, sigma 2 is going to be your longitudinal stress. Sigma 2 is equal to PD by 4T we had. When the longitudinal stresses are going to be acting on this member, then this is the circumferential direction, the material is going to be failing. So that's why efficiency C we are going to be taking. So that's going to be the efficiency of the joint, the efficiency of the material is reduces to 80%. So then what will happen? Your longitudinal stresses are going to be reach to the next level. Then automatically system will going to be fail if I am going to be using these calculations. That's why always we are going to be trying to find out what are the working stresses are going to be developing while you are using the components. So I hope you are able to understand how to identify the efficiency of the joints when we are using the different types of the joint like welding or bolted or maybe the riveted joints. I hope you are able to understand how to develop the mathematical model for the efficiency of the joint and the maximum shear stress, how to calculate it. So still if you feel any confusion or difficulty, please put in the comment section so that I can reach you out. Thank you.